so to start us off, go ahead and don't worry about that whole little where it's going to write definition example. I'm not going to do that anymore. Okay? What we're going to do is we're going to kind of focus in on what was represented in this POGL. Okay? So by the very end of the POGL, you had 4 things that you kind of had to think about when you were writing the manager's code, right? And what were a few of those things? The floor level was one.
Which room?
The room, right? So sunny rooms versus pink rooms.
And then number of people.
Number of people mattered, right? And what else? Number of bunk beds. Yeah, exactly. All right. So we're going to put these into more like our chemistry words so that now we can start looking at our periodic table and using that information there. Okay? All right. So what I want you guys to write first is we're going to talk about who those electrons were. Who were those electrons in the POGL? The borders, exactly. All right. And what did we use to represent our electrons when we were doing orbital notation? Or to show which bunk bed they were on? Not necessarily dots. What was it? The arrows, right. So we had upward arrows and downward arrows. Now, I write half arrows. You can do that, or you could choose not to do that. I don't care. Yeah, they kind of look like ones. Yep. Okay. I think it's easier when you're going really quickly. Okay. The other thing that was important about electrons, where did you have to look on the periodic table to get that last little... Right. There you go. The atomic number. So to know how many borders you had to go find that atomic number. Exactly. Okay. Is this zoomed in enough for y'all? Is that okay? Okay. If you guys need it more, let me know. All right. The next word, okay, that I'm going to put on here is energy level. What do you think represented our energy level? The floors, yep. All right, so which floor were you on? Okay, that was your energy level. When we get a little further in, especially when we talk about trends, you're going to hear me use the word shells. Okay? Because you can kind of imagine if you were doing somebody like cesium, which floor are you on if you're in a house? Which floor are you on? For cesium, find it. CS. Find it on your periodic table. So CS is on floor. Yeah, it's on the 6th floor, right? Now, when I use this word shells, if I tell you it has 6 shells, does it sound like a really fat atom or a really skinny atom?
Fat.
Yeah, exactly. And so what you guys are going to see is when we use that idea of the energy levels, we're going to be getting bigger as we move down our periodic table. So that's kind of coming in the future. All right. Your energy levels then, as you guys just showed me for cesium, you said it was on the 6th floor. You got that from periods. Right? So, and periods are your rows. The horizontal things. Okay? You guys sure I don't need to zoom in?
You can if you want to.
We are in 8th period. Just kidding. All right, hold on. Let me move this up. Is that better? All right, there we go. All right, so the next thing that we're going to write, okay, is sublevels. Okay, so sublevels. Where or what was giving us?
The sunny room.
Yes, good. The type of room. So you guys had sunny rooms versus pink rooms, right? And what those are going to show up to be are those are going to be our shapes. And basically you're shaping your electron cloud here, okay? So you're coming up with how many locations are these things are these electrons going to be found, possibly, okay? All right, so your shapes. So like we said, you guys had your sunny room, your pink room. There's also a D sublevel and an F sublevel, all right? So you have sunny, pink, and then D and F, all right? I have no special. What?
Yeah, it gets smaller.
All right, so we are going to just give a little preview. Make yourself a little... It is. No, it's... This is what I see. I took it off ninja mode, I promise. All right. Okay. And then kind of go like that, because that's a lovely periodic table. Can you guys tell it's a periodic table?
Yes.
Thank you. And then there's that. All right, so what we've got here is these first two rows. This is going to be S. This last portion over here, this is P, pink room. Got it, got it. And then this middle portion is going to be D sublevel. And then this bottom part is F. Okay? So you can kind of see that the rows got bigger, right? So what that tells you is your number of bunk beds, right? How many bunk beds did your sunny rooms offer?
3.
1. How many bunk beds did your pink rooms offer? 3. Okay, D is going to offer 5, and F is going to offer 7. So how many people can fit in the D rooms? 10. Good. And F is going to be 14. Exactly. All right, good. Okay, so that's kind of what you guys are going to be worrying about next. All right, after your sublevels, you also have orbitals. Okay, what was representing the orbitals in this Poggle?
Dots.
Nope, those are electrons. Your bunk beds, there we go. Okay, so what I like to think of is these are bubbles of space. All right, now, it's a nice way of saying three-dimensional area where an electron most likely is. That's why we say bubbles of space, okay? So it is, I'll show you an image here in just a second, okay? But these orbitals, you can think of as the bunk bed. You can only have 2 electrons total in them, and they don't want to be together if they don't have to be together. Hence the rule where you had to fill up all your bottom bunks first and then fill up the top bunks, because each electron wants their own space, their own little bubble world, and then once all the bubbles are filled, they're like, fine, you can share it with me. And then we put another one in there. But they have to have opposite spins. They're like, okay, but I'm spinning forward, you're spinning backwards, right? So, so that's kind of what that whole thing was about. One thing that I do want you to add to this, and you guys kind of saw this a little bit. We're just going to add in the X, Y, Z part, though. Okay? Is that those are your 3 different bunk beds. So then you would have started off up, 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 and then come back around, and you go down, down, and then down if we needed another one, okay? But those are, these right here are your orbitals, okay? Okay. And then finally, just like I said, they had their different spins and all that good stuff. Or I'm sorry, they each had to have their own bunk. That correlates with their spin, okay? So bottom versus top bunk. Okay? So your spin can either be forward or backwards. So if you've ever heard of a vector quantity, your spins are represented with vector quantity sign things, okay? So positive usually means in a forward direction, negative usually means in a backwards direction, okay? Your spin is why you fill up bottom bunk first, and don't share a bunk. Meaning you're either top or bottom. You don't get to share a bunk. Not allowed to, ever. Okay? It's not what bunk beds are made for. Just remember that. Okay? So this is what I wanted you guys to get from that whole Poggle thing. And honestly, now that you guys have done that and you have this analogy to fall back on, I promise the rest of this is super easy. It's just applying it to our periodic table now. Now, what I want to focus on before I move you, look how small it made it on mine. That's awesome. All right. I want to show you this little image and kind of show you what we're talking about there with the shapes, okay? So this whole first column right here, there we go. This whole first column, okay, those are cut in half. So what do you notice the S shape is? What would you say it is?
Sulfur.
If that's cut in half, don't those look like little jawbreakers?
No.
Yeah, they're a little ball, right? So they're spheres. Okay? Yeah, I know. All right, which also makes sense why there can only be 2 electrons in there. One going forward, the other one going backwards.
Why do they not crash?
Okay? Because they don't. They're repelling each other. All right. Then, this is the pink room over here. Okay? And what you notice is these tend to look, we tend to call these guys dumbbells. Okay? They look like dumbbells. And so, you can see that you've got those 3 different spaces. Okay? And so what you would notice is this would be something like boron, carbon, nitrogen. And then if we had to have another one, oxygen, fluorine, and then finally neon. Okay? So they're basically filling up these little bubbles of space. And that's what I wanted to show you with this. When you get to the middle area, they start looking like double dumbbells or flowers. These things tend to look like donuts right here in the middle. And then looking down here, you can see that those just get really stinking crazy, okay? So what I need you to imagine is when we're talking about these orbitals, these things are layered. They literally are going like in, like the spheres start out, and then you have the dumbbell kind of going at the same energy level, all right? Because what we're going to see is energy levels are going to kind of overlap in a part where one is going to be further away from our nucleus than another one is. And that's why we're going to be counting weird in a couple places, okay? So I want you to keep in mind these pictures. Are we all clear on how complicated and elaborate and amazing these things are? So these are basically probable locations of an electron. We cannot pinpoint any electron. They're moving so fast constantly. So these little bubbles of space are like, most likely it might be here at one point, maybe, possibly. That's what they're saying, okay? That's what an orbital is. Okay, I'm good with that for today. That's about as far as we got with everyone else. So you guys can enjoy your last 3 minutes.